Now, let's talk about the concept of lubrication. First of all, let me talk about something of contact and relative motion. You see here, my two hands are in contact and relative motion. I have nothing in between, so my two hands are, one rub the other. So I see frictions in between, all right? So here is another example. This is a rock drilling bit, okay, rock drilling bit. You see here is a shoulder shaft, and outside is a conic-shaped cutter. And the cutter rotates, okay, around the shaft and does the cutting action. So load basically is applied, which is due to the rock cutting, okay, in radial direction and also in the thrust direction. So if there were no lubrication, the surfaces would be just as what I showed as my hands are in contact, okay? And then the friction would be high and wear is expected. But if we do provide a thin film lubrication, provide a fluid film in between the two surfaces, and then the contact has to go through the fluid film, and the rotation basically is the shear of this fluid film, and shear of fluid give us low friction. So low friction and wear is going to be reduced as well. Okay, so we got a number of bearings over here. As you can see here, these two things, okay, in the cylindrical surfaces, if I cut through, this basically they are radial bearings. If I cut through this cross-section or cut through this cross-section, basically we should see the same thing. That is a shaft surface, okay? And here for fluid film lubrication, we call the shaft as a journal. And then the outside surface, which is the inner surface of the cutter, all right? And these two forms a set of bearings, all right? In between the two surfaces, we have this green color, the fluid film, all right? On the other direction, if you see this one, okay, in the front, we have two flat surfaces forming another bearing. Okay, so here two flat surfaces forming another bearing, and we have a wedge in between. Okay, and here we do have a wedge, and here we have a wedge in between. And then load is applied in this direction, corresponding to the thrust load in this direction. So we call this bearing journal bearing, and basically it is for radial load supporting. Okay, and we call this one slider bearing. Basically, so one slide on top of the other. So it is for thrust loading. Okay, as I mentioned, it's corresponding to this one. All right, so for two surfaces, if they're in contact and a relative motion, if there were nothing in between, these two surfaces would be under rubbing and friction is high. Okay, we want to build in between a fluid film. Okay, so if we have a thin fluid film, as what we do here, as what we do here, and then this thin film would separate the two surfaces, or the contact has to go through the fluid surface. And if we have a relative motion, and the relative motion would be the shear of the fluid film, then friction is low. The question is how to build this fluid film. All right, so we have two means. The first one is by relative motion. So by the motion one against the other, if we provide a wedge, okay, if we make this surface going in this direction and we drag in the fluid in between, so this is by relative motion. By motion, we drag fluid in between, and then we bring this film in between the two surfaces and form the film. And this film now supports the load. It separates the surfaces and supports the load. Okay, this is by hydrodynamic. So the first one, by relative motion, we call hydrodynamic lubrication. The other one is by external pressure. So we use external pressure to provide a pressurized, to squeeze the fluid, okay? The fluid is then pressurized. So by external friction to provide this film, but by external pressure to provide this film, we call this thing a hydrostatic. So no matter by hydrostatic means or by hydrodynamic means, once we have this thin film between two surfaces, and we have a means to support the load, we have a means to separate the two surfaces, and this gives us the friction reduction. All right.